Hi students, this is Mrs. Myers with a lesson on equations that have special solutions, or these are special cases of equations. So we've been solving equations in class, and we've learned so far that equations can have one solution. So looking at this scale here, we have on one side we have 3 boxes, and on the other we have 30. So the question is if each of these boxes has the same number, what number could we put in here to keep the scale balanced? All right, so the only number that will work for this is going to be 10 because they have to be the same. There are 3 boxes, and 3 times 10 is 30. The equation that we would have for this, if we showed this algebraically, would be 3x, right? If each of these were a variable of x, equals 30. And then to get that actual 10, we could divide 30 by 3. Okay, that's the coefficient here, and that's how many boxes we have. And then we could get our solution of x equals 10. All right, so that's an example of an equation that has one solution. All right, let's take a look at this scale. So on one side we have 20, we have a variable, and we have a variable on the other. So we're trying to figure out what number we could put in this box that's the same as this box that would keep the scale balanced. So we need both sides to have the same value. Algebraically, the equation would look like this. 20 plus x equals x. So see if you can figure out what number could go in each of those boxes. All right, let's try a couple. Let's say we put 10 over here. So I've had students say, well, this is 10, so then that means this is 30. That is a true equation, but it doesn't match our algebraic equation that we have here. Okay, and the reason why is it has to be the same number in each box. So 20 and 10, if I put 10 on this side, I would also need to have a 10 on the other. Okay, so let's try a different value. So I've had students say, okay, well, let's make this 20 over here. And then this then would have to also be 20. Okay, so this time we have the same number in each box, so that we did that, but is the scale balanced? All right, so over here now we have 40, and over here we have 20, and that is not going to balance our scale. We could keep going, keep trying, different values, but what you're going to find is no matter what you put in the boxes, if the number is the same, it will not keep the scale balanced. This is a representation of an equation that has no solution. There is no solution. There's no value for x that would make both of these values correct, right? Or the scale balanced. Because again, when we used the 10, like if I put 10 here, and this is 30, okay, they don't match. It's not the same number. But if we go ahead and make it the same number, and we put this as a 10, and then we look at what we have 30 equals 10, right? And 30 doesn't equal 10. Okay, now you have your note sheet. Let's go ahead and put this together. So this is our note sheet, special cases. So we're looking at no solution, when we have no solution. All right, let's go ahead and see what this looks like algebraically with one of the equations, the types we've been solving. So I'm going to first put my line down the middle. I'm going to do better than that. Put my line down the middle. All right. Okay, so our first step that we've been learning, when we're solving equations, we're trying to isolate our variable. We've got an x over here, x over here. So we have several steps we're going to go through to find the solution to this equation. So we're going to start with D for distribute. D for distribute. So I'm going to take the -4 right here. I've got this parentheses, these two terms in parentheses, and I have a number on the outside. Parentheses means multiply. So I'm going to multiply the -4 times 2x, which gives us -8x. And then the -4 times 1, which gives us -4. And on the other side, I'm going to bring down my -8x minus 2. All right. First step is done. We've distributed. Now we're going to go for S, which is sort. For sort, we want to put the variables on one side and the constants on the other. So starting on this side, I can see that I have a value with a variable here. I'm going to leave that on this side. And then I'm going to take this -4 and I'm going to move it to the other side. And remember, when we move a value to the other side of the equation, we are crossing the line. And when we cross the line, we change the sign. And the reason why is over here, if I wanted this to cancel out, I would be adding 4. That would then cancel this out. So the only thing we're not doing is putting the +4 on the side, because we're already moving it over here and we're canceling it out. All right, let's do the same thing with our -8x. So our -8x, if I take it over to this side, right, that would be crossing. I'm going to take my -8x and I'm going to cross the line. Okay, I cross the line. I want this to cancel out, so I would actually be adding 8x to cancel out. So I'm going to add 8x also to this side. Okay, that's our sort step. Now let's go on to the combine. So now I'm going to combine any like terms that I have. So over on this side, -8x plus 8x. So if I have 8 negative x's and 8 positive x's, what's going to happen is when you put these together, you actually get 0. They cancel out. On this side, I have -2 plus 4, and -2 plus 4 is 2. And that would be our combine step. Now normally our last step would be divide, but there's nothing to divide here because our variables canceled out. And that is the key when you have no solution, or another special case, but we're talking about no solution right now. Your variables are going to cancel out. So you can see that our variables here canceled out. The other thing we're going to look for is what kind of equation we're left with, right? This is an equation because we have an equal sign. 0 equals 2. Does 0 equal 2? No, it doesn't, right? 0 does not equal 2. This is a false equation. So when your variables cancel out and you are left with a false equation, your answer is no solution. There's no possible solution. That means there's nothing you could put in for x that would make both of these sides the same. All right, let's take a look at another picture model before we look at the other special case. All right, over here, we're going to write a number in each box so that the scale is balanced. So think about a number, and this would be algebraically like, this would be like x equals x, right? Each of these boxes is going to represent the same value. So let's think about a number that we could put in, if we can, that would make this balanced. All right, so we could try some of the numbers we tried with the last example. So if I put a 10 over here, has to be the same, and I put a 10 over here. Okay, 10 equals 10. Okay, so that works. But is that the only solution that works? Let's try another one. We could try -6. If I put -6 on this side, and I put -6 on this side, they are equal. Okay, that also works. So this is true, this is true. You're going to find no matter what number we put in, because it's saying x is equal to x. No matter what number we put in here, 4.7. If I put 4.7 over here, 4.7 is equal to 4.7. So now, no matter what I put on each side, we have the same number and the scale is balanced. All right, so I could put any number. This is an example of another special case when an equation has infinite solutions. No matter what I put over here, if I put the same thing on the other side, this scale will stay balanced. All right, let's take a look and put this together with an algebraic equation. All right, so this is an example of infinite solutions. Our I's cut off here, but your notes should say infinite solutions. So I'm going to start with my line. We're going to solve just like we know to solve our equation here. We're going to start again with our distributive property. So we're going to start with D for distribute. And then that's right over here. Okay, I'm going to look for any parentheses with terms and then look for the number on the outside. And I'm going to distribute. 3 times 1 is 3. 3 times -3x is -9x. And then I'm going to just bring down my -8. On the other side, I'm going to bring down what I had. -5 minus 9x. I didn't do anything to that side yet. All right. Next step. Okay, now we have variables on both sides, so I'm going to S for sort. So on the left side, I want the variables, and on the right side, I want the constants. So I'm going to take this -5, and I'm going to move it to the right. So if I take my -5, and I move it, if I want it over here, I'm crossing the line. When I cross the line, I have to also change the sign. So instead of negative, it's positive. All right. The -9x is going to stay over on this side. But on the right now, I have a constant. This will stay. The -8 will stay, but what's going to move is this -9x. -9x, I want to put it on the other side. -9x. If I move it to the other side, I'm crossing the line, and when I cross the line, I am changing the sign. All right, our next step is our C step, which is to combine. So C for combine, so I'm going to take any like terms that I still have, right? I canceled this out. Oh, and I canceled this out too. So I brought it over here. All right, so on this side, you have -9x plus 9x. -9x plus 9x. These cancel out, so this is actually going to be equal to 0. So I have 0 on the side, right? The -5 I'd already moved. These two, I have 9 negatives and 9 positive x's. They cancel out. 0. over on this side, I'm going to combine my 3 minus 8 plus 5. 3 minus 8, right? 3 minus 8 is negative 5. 3 minus 8, negative 5. And then I got to add that 5. Negative 5 plus 5 is going to give me 0. So I have 0. Now, my equation that I end up with is 0 equals 0. My variables canceled out, right? Just like the last one. Your variables cancel out. That's really important. And you are left with, let's look at what kind of equation this is. This is 0 equals 0. Yes. This is a true equation. This is true. 0 equals 0. So when you are left with a true equation, your answer is going to be infinite solutions. And actually, I think on your notes it says something, I made this a little bigger, but it's the same, right? True equation means same answer on each side. So there's another blank on yours where you're going to put same as the same answer. So this is our second type of equation when we have infinite solutions. Second special case. All right, let's do a couple of these examples from the note sheet, and then you're going to try some on your own. But we're not going there yet. All right, let's take a look at number 1. And let's put our line down. Okay, we're going to solve these just like we do, the same steps. It's just the solutions are going to look different sometimes. Not always. Some of these equations will have one solution. So I'm going to start with my distributive property. 3 times 2x is 6x. 3 times 2 is 6, right? Start there. And then I'm going to bring down my negative 3x equals 6 plus 3x. Next step, we're going to S for sort. So I want my variables on one side, my constants on the other. Over here, I have a constant. We have a positive 6. When I move my positive 6, right? If I have a positive 6 and I move it over here, cross the line, instead of positive, it's now going to be negative. And it cancels out over here. On my right side, I have a positive 3x. I'm not bringing the plus sign over because it's positive with or without the plus sign. And it makes it easier for me to change the sign. So 3x, we're going to pull that over to the side so we can combine our variables. So 3x, if we move it over here, I'm going to go ahead and just put it right here. Now, instead of a positive, this is going to be a negative 3x. Cancels out. All right, now our next step is going to be combine. C for combine like terms. So we have, now again, now we're combining. When we're combining, we don't change any signs. Right? They're on the same side. We can just put them together. So we have 6x minus 3x, which is 3x, positive 3x, and then minus 3x, right? Because you have, let's put it over here, over here. 6 minus 3, right? We subtract our coefficients, that's 3. And then this other one here, and then 3 minus 3, that would actually give you 0. So over here, because I have 6 minus 3 is 3, and then 3 minus 3, which is 0, this is actually going to give me 0. My variables have canceled out because 6 minus 3 is 0. All right, and now on this side, I have 6 minus 6, which is also 0. So now we must ask the question, is this a true or false equation? Is 0 equal to 0? And the answer is yes, it is true. If it's true, that means your equation has infinite solutions. No matter what you put in for x on one side, it's going to be the same number on the other, and it's going to keep the equation balanced. So no matter what you put in for x, if you put the same number on the other side, this equation will be true. So this has infinite solutions. All right, let's take a look at number 2. All right, we're going to bring down our line. We're going to start with distribute. You can see here we have distributive on both sides. So we're going to take care of that step for both sides. 6 times 2, 12x. 6 times negative 6 is negative 36. Negative 7 times negative 2 is positive 14x. And then negative 7 times positive 4 is going to be negative 28. Next step is going to be our sort, distribute, sort. I'm going to want to take this negative 36. I'm going to move it to the other side. So instead of negative 36, it's going to be positive 36. I'm going to take this 14x. I'm going to move it with my 12x. I need to put all my variables together, but when I move it, I'm going to make it opposite. So 14, if I move it over, is going to become negative 14x. Next step is C for combine. 12x minus 14x is negative 2x. So 12 minus 14 is negative 2. And then on the other side, I have negative 28 plus 36, which gives me 8. And then my last step, this time we did not cancel out our variables. They didn't cancel out. When we do our last step of dividing, let's just go with this. D for divide. We're going to divide both sides by the coefficient. And if the coefficient is negative, we're going to divide by negative. Negative 2x divided by negative 2x is 1x, which is just x, right? And then 8 divided by negative 2 is going to be negative 4. So this is an example of an equation that has one solution, just like the ones we've been solving. I don't want you guys to think every equation now that we practice is going to have infinite or no solution. We can also still have equations that have one solution. All right, let's jump ahead because I want to have one of each type. So let's skip number 3 for now. You can go back and do that one later. And now let's go to number 4. So go to number 4 on your note sheet. We're going to put our line down the middle. We're going to start with our distributive property. This time we have distributive property. We have 2 places where we're going to distribute on the same side. And right here, when you're distributing here, you notice how that's a minus 4 times x minus 7. You need to make sure that you are distributing that negative 4. So I'm going to do 7 times x, which is 7x, 7 times 2, which is 14, negative 4 times x, which is negative 4x, and negative 4 times negative 7, which is positive 28. On this side, 3x minus 13. Just bringing it down. All right, my next step is I'm going to sort. S for sort. I want to move my negative 13 to the side with the constants. So I'm going to, it was negative. Now it's going to be, I'll just put it underneath this 14. It's going to be plus 13 or positive 13. All right, and so now I have some stuff on the right, some terms on the right I'm going to move over that are variables. So I have 7x. If I move this over here, I'm going to put it right underneath negative 7x because it crossed the line. And I'm going to take my negative 4x over here. I'm going to move it over here. So this is going to be 4x positive. And now I can combine my like terms. C for combine. So I'm going to put together my like terms. 3x minus 7 is negative 4x. Negative 4x plus positive 4x will give me 0. So our variables canceled out, right? Because 3 minus 7 is negative 4. Negative 4 plus positive 4 is 0. It's 0x, right? But we're just going to write that as 0. If I have 0x's, I'm just going to put 0. I have 0 on this side. And then on the right side, I have 14 plus 13, which is 27. And then I have 28 over here. So 27, right? 27 plus 28 is 55. So variables canceled out, right? So we canceled those out. We got 0 on one side. And then on the other side, when we combined the constants, we got 55. Is this true or is it false? Is this a true or false equation? Well, 0 is not equal to 55. So this is an example of an equation that is false. Because it's false, that means no matter what number I put in on one side, there is not the same number that I can put in on the other to balance this equation. So this equation would have no solutions. No solution. All right. So today we learned about special cases of equations. So while you're solving your equations, pay special attention. And what we need to remember is if the variables cancel out, right, and you end up with 0, it's like we had this one with no solution. This one over here, it also cancels out, but we had a true statement. We can either have infinite solutions as a solution, one solution, or we can have no solution.